Hello everyone. In this video we're going to be solving a really cool geometry puzzle. A circle with radius r, a semicircle with radius 3, and a quarter circle with radius 2 are inscribed in a semicircle as shown. Find r. Alright, awesome. At this point, if you want, you can just pause the video and try this problem first. Alright, let's get started. So, we do have a semicircle whose radius we do not know. And a circle, a semicircle, and a quarter circle are inscribed in it. And we do not know the radius of the circle either. But we know that this is a 2, and that's a 2. And this is a 3. Okay, and this is the center for the larger semicircle, right? This one here. We're going to find out. So we're going to start by finding the radius of the larger semicircle. So let me go ahead and make a very crucial connection here. We'll start with that. And again, I can use my fancy pen, right? So let's go ahead and connect these. Now, by making this connection, actually, I'm able to find the radius of the larger semicircle. So how am I able to do that? Let's see how that works. Well, we got to find this distance first, right? We don't know this length here. Okay, so how do I find it? This is a right angle. So I do have a right triangle. I know the height is 2. I got to find the base. And I can just designate something for the hypotenuse as well. What's the hypotenuse? Let's start with that. The hypotenuse is the radius of the larger semicircle. So let's call that big R. We're going to save the small r for this guy here. Okay, we're going to save that small r for that one. Okay, so what do I have here? I need to find this length. So this is 3, then this is also 3. That means the diameter for the green semicircle, the smaller one, is 6. Well, from the 6, you're basically just subtracting the radius of the larger semicircle, which is r. So this length is going to be 6 minus r, correct? Okay, awesome. Now that gives me something to work with, because now, as you see here, I have a right triangle, right? And now I can write the base in terms of r, and the hypotenuse is r. So we can build our equation here. Let's go ahead and do that. So this gives me 2 squared, which is 4 plus 2 plus 6 minus r, which is 8 minus r quantity squared. That is equal to r squared. Awesome. So this equation is going to give me the radius of the larger semicircle, which I have to find first before I can attempt to find the radius of the circle. Okay, so let's go ahead and expand this. 4 plus 64 minus 16r plus r squared is equal to r squared. One thing that's good about this is not going to be a quadratic equation. So simplifying this would be a piece of cake. Let's go ahead and do that. R squared cancels out. We end up with 0. So what I can do is I can write this as 16r is equal to 64 plus 4, which is 68. If you divide both sides by 4 and get the r by itself, you should be getting 17 over 4 for the radius of the larger semicircle. Okay, so we were able to find the radius of the larger semicircle, which is big R, and that is equal to 17 over 4. So what I need to do next is find the radius of the blue circle. There's only one circle, so you can't really get confused here, right? Okay, cool. How am I going to find that? I need to make more connections here. But since we already made some connections and it's going to be confusing if I continue to do so, I'm going to go ahead and clean this up. Let me go ahead and clean this up a little bit so that I can work on the same figure again. All right, so it's now clean. And then what I'm going to do is I will be making some connections here. So let's go ahead and make some good connections. Which connections are we going to need? We're going to need a lot of connections here, obviously. Okay, so let's start by connecting the centers first. The center of the circle to the center of the semicircle, like this. Okay, that's one connection I'd like to make. That doesn't look good. Let me redo it. And I could probably make a better one if I just go ahead and hold on to it like this. should be straight. Okay. And then I can also connect the center of the quarter circle to the center of the circle, which is also going to be helpful. And you're going to see in a little bit why. Okay. I need one more connection, and that connection is going to be from the center of the green semicircle, the smaller one, to the center of the circle. So that's another critical connection that I need to make, like this, okay? So let's go ahead and label all these lengths. So we know that this is a big, well, this is actually 3, not the big one, right? That's a 3. And then this is going to be the small r, which I'm trying to find. This is also small r. Now think about this. This whole thing here from this point to that point is going to be the big R. If I subtract the small r from it, this should be big R minus small r, correct? Okay, I got that length as well. Let's go ahead and find this one. This is a 2, right, the quarter circle, and this is the small r. So I got pretty much all the lengths that I need, but I will need to make more connections here to be able to find these lengths, okay? Because we're not going to go into anything crazy like law of cosines or law of sines. So I do need right triangles. How do I make right triangles? Well, you can just go ahead and drop a perpendicular line here. Let's go ahead and do that. So something like this. I will drop a perpendicular here. And that's supposed to help me, right? Okay, because now this gives me right triangles. Awesome. Great. So let's go ahead and label this. Some lengths here that we have, right? Okay. So let's call this h first of all, the height of this triangle, or more than one triangles actually. Now, I do not know this length, so let's call that x, this little tiny piece here. And this one. Now, think about this one. This is 3, right? Okay, that's a 3. And what do I know about this? Well, this is actually, I actually used this before, right? So this was 2 minus r, wasn't it? No, 6 minus r. Okay, so this 6 minus big R. And why is that 6 minus big R? Because this whole thing is 6 from this point to that point. And from that, I'm just subtracting. I don't think I need this. From that, I'm just subtracting the whole thing. So this is the big R, right? And the whole thing is 6. So it's 6 minus big R. Awesome. I know that too. But now I got to find this. Awesome. How do I find this piece? Well, to find that piece, actually, are we going to need that piece actually? Yep, we are going to. Well, we're going to need the sum. So from this point to that point, it should be the 3. So this should be r minus 3. Does that make sense? Because what happens is if I add the 6 minus r to it, I'm going to be getting 3 from here, which is correct because this is 3, right? That's a 3 and that's an r, so that should be good. Okay, it makes sense because this is also 3 and then their sum gives me the big R. So this should work. Awesome. Then maybe get rid of these because they kind of look confusing here. Awesome. So this is r minus 3 and I don't think I need that either. And that's 6 minus r. Cool. Now what we're going to do next is using these relationships, we're going to be writing equations. Let's go ahead and write them. But what about this length? This must be 2 minus x, right? Because this little piece I took out is x, so, and the radius of the quarter circle is 2, therefore it needs to be 2 minus x. Okay, so let's go ahead and write down our equations, but there's going to be quite a few, so we probably need some good space here. Let's go ahead and use this space for that, and I could probably use something nicer, like this color. Here we go. Okay, what's my first equation? I'm going to be considering this right triangle here first, all right? So this right triangle, this one, that's going to look like 2 minus x squared plus h squared is equal to 2 plus r squared. Now notice that x is unknown, h is unknown, and small r is unknown. 3 unknowns. Okay, great. And then I'm going to be using this right triangle here. That's going to give me x plus 6 minus r. Notice that the base is not just 6 minus r, but x plus 6 minus r, right? Squared plus h squared, I have the same height here, right? So it's going to be plus h squared. And the hypotenuse is big R minus small r squared, right? But I know the big R, so I'm going to replace that. Otherwise, we'll have 4 variables. And then I will be considering the triangle with a larger base, this one, right? And that is going to be 6 minus r plus r minus 3, which is 3 plus x, okay, 3 plus x squared. And then the height is going to be h squared again. So for all these triangles, they have a common height, which is good. And the hypotenuse is going to be 3 plus small r squared. Beautiful. So I have now 3 equations, and I should have 3 variables. But guess what? I know that the big R is 17 over 4. So what I can do is I can do the replacements. But let's simplify this as much as we can first. Then we can always do the replacement. But maybe for this one, I think I'm going to do the replacement because that's going to kind of make the equation look simpler. So let me go ahead and start with that. Or I can save it for later. Let me see. Okay, I'm going to work with these 2 equations first. Because what happens is I can actually get rid of the h squared and find a relationship between x and r, and then substitute that in the second one. So let's go ahead and isolate h squared from both of these equations and set them equal to each other. So h squared equals h squared. And this should greatly simplify things, you'll notice. Okay, makes sense? I isolated h squared here, and then set them equal to each other. Beautiful. Let's see what happens. 4 plus 4r plus r squared minus 4 plus 4x minus x squared. Unfortunately, we didn't get a negative x squared, but we'll get that over there. That's good. 9 plus 6r plus r squared minus 9, not 6. It should be 3 squared minus 9 minus 6x minus x squared. Awesome. So now we are able to simplify these here. R squared minus x squared, r squared minus x squared. Beautiful. I'm going to get a relationship that's linear, which is cool. So I'm getting, and 4 minus 4 is also 0. So that's good. I have 4r plus 4x is equal to 6r minus 6x, okay. Okay, so this is good because all the numbers are gone, right? And what I have left is actually going to be some nice ratio between r and x. This is cool. I like that. So if you collect all the r terms and x terms on either side, 10x is going to equal to, I wasn't expecting this actually. Anyways, so from here I get r equals 5x. Beautiful. I love it. Okay, so since r equals 5x, I can plug in into one of these equations and actually get something nice. But we're also going to have to involve h at some point, right? So here comes our next equation, the second one. So we can also work off of that, and eventually we're going to be able to find everything, hopefully, right? So, but at least I have something good that looks like r equals 5x. Notice that x is small. That's why it makes sense that r is going to be 5 times that, because x is super small. X is tiny. Okay, cool. Remember, our goal is to find r, but we're going to have to find the other variables in the meantime. So here, what I can do is, in the second equation, I can substitute everything that I know, right? So that's going to look like what? Here, x is equal to something, like we can call that x, I guess, right? Plus, and then I have 6 minus r. And r is 17 over 4, remember that. So this is cool because that only gives me an equation in x, which is nice. Squared, and then plus, I have h squared. Remember, I'm using the second equation here. Equals big R minus small r squared. So big R is 17 over 4. And small r can be written as 5x. And that's just going to be squared. Awesome. So here, this gives us h in terms of x. So I was able to find r in terms of x, h in terms of x. Then what we're going to do is we are going to use it in one of these equations then hopefully we're going to be able to solve it. But h squared is in the equation, so if I can get h squared in terms of x squared, that's fine. I don't need h. I don't need to square root this. Okay, awesome. Let me simplify this a little bit. H squared is going to equal what? Oh man, this is going to be like a difference of 2 squares. So what I could possibly do is without, or should I do that? Well, I'm thinking I could possibly use some difference of 2 squares. Let me see if that works. I think it's going to help. Let me do this. This squared minus, okay, that guy is going to be 24 minus 17, 7 over 4. So it's going to look like this. Cool. So from here, let's go ahead and use the formula for difference of 2 squares. Well, it says that you got to add these first. So when you add them, I think it's going to be nice. 17 over 4 plus 7 over 4 is going to be 24 over 4, which is 6. And the sum of negative 5x and x is going to be negative 4x. So this is their, what? Sum. And the difference is going to be 17 over 4 minus 7 over 4 is going to be 10 over 4, which is 5 halves. And then their difference is going to be negative 5x minus x. That's going to be negative 6x. Great. And obviously there's a factor of 2 here, which I can use to simplify this. But what I would really need is just, I got to distribute these and get a nicer expression. Let's go ahead and do that. Okay, awesome. 6 times 5 half is going to be 15 minus 36x. And this is going to be minus 10x plus 24x squared. Great. H squared is going to equal what? 24x squared minus 46x plus 15. Awesome. I was able to get h squared in terms of x. I was able to get r in terms of x. Let's copy that here. R equals 5x. And I was able to get what else? Well, we know the big R, so I think we're good to go. So now what I'm going to do is basically I need to plug these into an equation that I haven't used. So it might be either the first one or the third one because I used the second one. I think I'm going to use the bottom one. 3 plus x squared plus h squared is equal to 3 plus r squared. Awesome. Now, if I'm able to find anything from here, x or r or h, doesn't really matter, I can find the other ones. Well, I would love to find x first because then finding h would be easy. But remember, if I can find x, then I'm good because all I need is the radius and it's right there. Awesome. Let's go ahead and solve this system, or whatever we're going to call that. Since everything is written in terms of x, I can just go ahead and use that. This plus h squared. H squared is 24x squared minus 46x plus 15 is equal to 3 plus r, 3 plus 5x quantity squared, which I need to expand, right? So I got to go ahead and expand it. Let's expand everything. 9 plus 6x plus x squared plus 24x squared minus 46x plus 15 is equal to 9 plus 30x plus 25x squared. Now, what's really cool about this equation is that x squared plus 24x squared is equal to what? 25x squared. And guess we have what on the right hand side? 25x squared. Beautiful. So this should give me something nice, hopefully. Let's see. I have 9 plus 15, which is 24, minus 40x is equal to 9 plus 30x. So what I can do now is put the 40 on the right-hand side. That gives me 70x, and 24 minus 9 is going to be 15. Okay, awesome. So from here, I should be able to find x finally. Wow, what a relief, huh? Okay, we're going to divide both sides by 70, and that's going to be 15 over 70. And if I simplify this, x is going to equal 3 over 40. Beautiful. Yay, I found x. Okay, now what I can do is I can actually substitute this x here, right? And find the value of r, and then I reach my goal. R equals 5x. Therefore, from here, r is going to equal 15 over 14. So that's the radius of our circle here. Let me show you the picture one more time. Here we go. X is equal to 15 over 14. So x is slightly greater than 1. And I think it makes sense because if you look at the quarter circle, its radius is 2. And r seems to be less than that, but not necessarily half of that, maybe a little greater than half of that, which makes sense again. Okay, so that's cool. We found the answer, and the radius of the circle we're looking for is 15/14, and that's the end of this video. Well, thank you for watching. I hope you enjoyed the video. Please comment, like, and subscribe, and I'll see you in the next video. Until then, take care. Bye-bye.